In our last lesson, we spoke about equal fractions, and that would be useful for this discussion. And so, therefore, I think just to begin with, we will do a recap. But we do the recap in using it for this edition. So here we are adding a third, which the division of it is of portion size 3, and a 2/5, which the portion size of it is a fifth. So as you can see, the denominators here, which are the bottom numbers, the denominators which show how many division there were in the original whole number, and these two numbers are different. And so let's just quickly go back to the discussion that we had in our previous lesson. And what I am going to do is, so if you remember this bar of chocolate, we broke this bar of chocolate into 15 equal pieces. So it's 5 there, 5 there. So that's 15 equal pieces. So in fact, each one of these pieces here is 1/15. Yeah. Same here. Each one of these are 1/15 of the whole thing. So 15 of them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15 of them makes the 15/15th, which is the whole thing. Now, if I snap this bar here, so if I snap it in the middle here, and I break it into 3 pieces, then each one of these will be a third. So really this third here, I'm going to make it blue. So this third here is one of these pieces. So that piece there, that piece there is a third. Yeah, the whole thing. One of these pieces here is a 15th. One of the small ones is a 15th, but the whole thing is a third. So as you can see, 1, 2, 3, 4, 5. 5/15th is the same as a third. Yeah, and so I'm going to just write it here. So 5/15th. So 5/15th is the same as that third. Yeah. Now in the other picture, if I now break the so if I break the thing here, if I snap it here, and in fact I snapped it there as well, and there, and there. Each one of these sections, the whole section, would be a fifth. It would be 1 out of 5 pieces. So if I select 2 of them, and I'm going to select these 2. If I select these 2, let's make it red. So if I select these 2, then that would be 2/5. But as you can see, it's 1, 2, 3, 4, 5, 6. So 6/15th is in fact the same as 2/5. Now, we couldn't add these together because, of course, the portion sizes are the same. So you can't say that portion, which is a bigger portion, than these 2 portions, which are smaller together. So each one of these is a smaller than one of these. So these are different sizes, so you can't add them together. Just the way they are, you can't add them together. You have to make them the same size. Remember, in maths, you can only add similar quantities to one another. And so the same quantities, the same portions can be added together. So instead of adding this to this, so instead of adding this to this, we can add this to this instead, which will give you 11/15th, because you have 5/15th there and another 6/15th. So if you count them up together, you would get 11 of these pieces. 11 of these pieces will be 15. It will be 11/15th. Now, so that's the reason, and I think it's very important that your learners um, get used to when they're learning maths is important that they get used to wanting to know why rather than just how. Because when they are just concentrating on how, they're relying on their memory rather than their power of deduction and reasoning. And memory would have a limited capacity. So it would reach a point in their learning of maths where not only the number of procedures become too many to remember them all, but also the procedures become longer and more complex and more about them, more twists in them. And so it would be more difficult to actually remember just one procedure. So it is important that these procedures, these hows, are backed up by whys and the reasoning behind them. So once they know the reasoning, then we can really go back to equal fractions that we done in the previous lesson. So as you know, a third is equal to, so if I double the top and double the bottom, I get 2/6. So a third is equal to 2/6 as a fraction. These look different, but they actually are indicating the same quantity. So, or I can treble it. So if I treble the top and treble the bottom, I get 3/9. Yeah, so I trebled the top and I trebled the bottom. And you can go 4 times or 5 times. So if I make top 5 times bigger, then I get 5/15, and the bottom, of course. So 5 times the top and 5 times the bottom. So 5 times the top and 5 times the bottom. I get 15th. So you can see how a third is in fact the same as 5/15. And the same discussion can be done about this. So if you double this, you get 4/10. If you treble it, if you treble the top and treble the bottom, treble the top, treble the bottom, you get 6/15. Now, so when you arrive at equal fractions where they have the same denominator, when they have the same denominator, yeah, this is called common denominator. So the common denominator allows you then to just count on, because they all will be the same sizes then. You will be allowed to count on. So the question would be, how would I know which denominator will eventually be common? Of course, the easiest way of thinking about this, which perhaps you would be taught at school in as a procedure, is that to find the common denominator, the easiest and the laziest way of doing it, is just to say 3 times 5, 3 times 5 is that common denominator that you're looking for. So that's how the 15 came about. But of course, in some numbers, this just multiplying the two numbers might give you too large a number to deal with. So maybe you have to think a little bit carefully about choosing what number is the best. But either way, both of these numbers, 3 and 5, need to be divisible into this common denominator. So you need to be able to somehow go from 3 to 15th. And as you can see, to go from 3 to 15th, I'm multiplying here by 5. And to go from 5 to 15, I'm multiplying by 3. So that tells me that whatever I've done to the 3 to get here, I need to do to 1 to get to its equal fraction. So 1 needs to be also made 5 times bigger, which would give you 5. And 5 to reach 15 is being made 3 times larger. So that's what I have to do to the numerator as well, to the top number. And so that needs to be made 3 times bigger, which gives you the equal fraction to the 2/5, 6/15. So 6/15 is actually equal fraction. So that's how the common denominator is decided on, and that's how the numerators are adjusted so that this fraction is the same as that fraction, and then this fraction with the common denominator is the same as this fraction. And now that we have the common counting measure, the actual quantity is now 15th, we can then just join them together because now we are counting the same quantities. So 5/15 and another 6/15 together, it gives you the result of 11/15. Of course, now that you've done this, then you can try different questions. You can find those in some of my resources that is online. But it's small. So start with small numbers. So, for example, there's 3/5 plus 2/7. Yeah. So, can you immediately tell me what the common denominator for 5 and 7 would be? Easiest way is just to multiply them. 5 times 7 would be 35. And then you will have to adjust the numerators. So this numerator has become 7 times larger. Sorry, this denominator has become 7 times larger. So this numerator needs to be made 7 times larger. Yeah. This denominator, to go to its equal fraction, has been made 5 times larger. So therefore, this will have to be made 5 times larger. Yeah. So that's the equal fraction to this, and this is the equal fraction to this. And now they are all the same size. These are portion sizes of size 1/35. Very small portion sizes. So now we can actually add them together. So this will give you the sum of 21 and 10. So 31/35. I hope you found this useful.